All right, welcome back. Hopefully you were able to tape in your perfect cubes chart into your composition notebook. That is going to be one that we do not want to lose. We want to memorize those. And so basically now I'm just going to focus on showing our work here and how I expect you guys to show your work. It's very, very similar to what we would do with perfect squares and square roots, okay? So there's not a lot of work required, but there is some, and you must show it. Okay, so the first step that we're going to do, we kind of talked about it in the perfect cubes chart. We want to remember, though, that when we're taking a cube root, this is our radical, okay? This right here indicates that it's a square root, but I need to write the little 3 right here to indicate that this is actually a cube root. Okay, and that does make a difference. That's probably one of the biggest things that people forget to do is to write that 3, and technically it's wrong if you don't write that because you're finding the cube root, not the square root. Okay, because remember, a cube root undoes a cube. Okay, so let me get this a little clearer here. We're going to start with the first one. So obviously we have it already written, x cubed equals 64. And what you're saying to yourself there is you're thinking, what number, if I multiply it by itself 3 times, is going to equal 64? Okay, so it takes a little bit of thought. We're only going to give you the numbers between 1 and 125 as your perfect cube. So if you get to know those, it'll be pretty easy here. So if I think about this, and if I look at my perfect cubes chart, which this is a perfect cube, the number that would be 4. Okay, but I can't just write x equals 4. I have to show my work. So the way I'm going to show my work is just like we do with square roots. I'm going to draw the radical symbol over it, but I have to remember to put that 3 on both sides, okay, because I'm taking the cube root of both numbers, okay, not just the square root. So next up, I'm going to, if I take the cube root of x cubed, basically the cube root undoes the cube. So we're left just with x. We have to have that. We have an equation, so we need to continue to have an equation. And we already talked about here that the answer would be 4. Now, the important part here is that when we're taking square roots, we have 2 answers, a positive and a negative. And the reason that is because if we're taking a square root, the number times itself and the negative number times the negative number will also equal a positive. But cube roots only have 1 answer. The reason being is because if I were to do 4 times 4 times 4, it equals 64. But if I were to do negative 4 times negative 4 times negative 4, then I would get a negative 64. So cube roots only have 1 answer. So I'm going to write that off to the side. Only. And so that's another big thing is that when people turn in their homework, a lot of times they're used to just putting a plus or minus with these types of problems because they're used to square roots. But you have to have that knowledge that when you're taking the cube root, there's only 1 answer. Okay. So then if we take a look at the next one, the thing that's a little bit different about this one is that we actually have a negative number. Now, if we were doing a square root, that wouldn't be possible. But if we think about taking the cube root, and again, I'm going to show my work here, okay, writing the 3 in the pocket there, I'm taking the cube root of y cubed, which I know will just be y. And what I think over here, I've got negative 27. So if I look at my perfect cubes chart, well, I know that the cube root of 27 is 3. So if I think about the cube root of negative 27, it's actually going to be negative 3. And the reason that is because negative 3 times negative 3 times negative 3, I know a negative times a negative would be 9. So a negative times a negative equals a positive. And then I have to multiply by negative 3, and I'll get negative 27. So it is possible with a cube root to have a negative number. Okay, so our answer would just be y equals negative 3. So not a lot of work required, but you do need to show this step here. Okay, this is just proof. You don't have to show this, but these 2 things you need to show. Okay, and you need to end with an equation. Next up, we've got another fraction. Okay, and so these are very similar to what we did with square roots. I'm going to take the cube root of each side. Okay, I'm lucky to find that both 8 and 125 are perfect cubes, so that's good, or else we'd have a hard time with this. I know that if I take the cube root of a cubed, I'm going to get a. And then just to make my life a little bit easier here, I'm going to take the cube root of 8. I'm going to separate it from the cube root of 125. And I'm just showing that I'm taking the cube root separately of the numerator and then the denominator. Okay, and so when I do that, I still have a over here, and I know that the cube root of 8 is 2, and the cube root of 125 is 5. And since I know that there's only one answer, my answer is just a equals 2 fifths. But you do need to show these steps. Okay. You can give a pause and see if you can try number 4. It's very, very similar. Okay. So you can click pause if you'd like. I am going to continue working though. Okay, so for number 4, I'm going to take the cube root of x cubed and the cube root of 8/64. I know that the cube root of x cubed is x. And over here, again, I'm going to separate my numerator from my denominator. I know that the cube root of 8 is 2, and the cube root of 64 is 4, but I'm not done. Okay, so what I would need to do here is still simplify. Okay, I always get the question, should I simplify? If it's possible to simplify, you want to simplify. Okay, so I'm going to divide these by 2. And so my answer will be, and I'm just going to rewrite this officially, x equals 1/2. Like so. Okay. And finally, number 5. There's a reason we put in number 5. If you look closely, hopefully you guys can see better than I can see here, this is no longer a cube root. The biggest thing people do is that they don't pay attention to squared or cubed. This is actually x squared. So we have to remember what we did last week and not use the cube root symbol. You only use the cube root symbol if you have something cubed. We're going to use just the regular radical square root symbol if we have something squared. Okay, but same idea. I'm going to take the square root this time though. So I still have to show that symbol. I know that the square root of x squared is x. I'm going to again separate the numerator and the denominator. They're both perfect squares. I know that the square root of 36 is 6, and the square root of 64 is 8, because 8 times 8 equals 64. But this time I have to remember that with square roots, there are 2 answers, plus and minus. Okay, so that's the big difference that we have to remember. And finally, last step, we do need to simplify. So I know that these are both divisible by 2. So my final answer is going to be x equals plus or minus 3/4. And that's my final answer. Okay. So now it's going to be time to try your independent practice. Good luck.